Hi, this is Sabir again. Uh, in this lecture, I'm going to discuss all about the stress invariants. Stress, stress invariant. Say we have a so for an stress tensor, say sigma for a stress tensor sigma, the characteristic of this stress is determinant. So from the tensor lecture, we have already known that determinant of sigma minus I lambda if determinant that is equal to 0. So this is the stress tensor, is the identical matrix, and this is the eigenvalues, right? So determinant of that is equal to 0. So if it's sigma, say you can write down sigma 1 1, sigma 1 2, sigma 1 3, sigma 2 1, sigma 2 2, sigma 2 3, sigma 3 1, sigma 3 2, and sigma 3 3. So this stress tensor minus identity alpha and identity matrix 1 0 0 0 1 0 0 0 1. So this identity matrix and the determinant of the whole is equal to 0. So alpha times this, so this should be alpha and this term, oh sorry, this 1 and 1 times alpha is equal to, so alpha is 0. So from this uh, we can write here sigma 1 1 minus alpha 1 2 sigma 1 3. Yes, so sigma 1 2 sigma 2 2 minus sorry, of sigma 2 1, right, sigma 2 3 sigma 3 1 sigma 3 2 sigma 3 3 minus alpha, and the determinant of x is equal to 0. So from the determinant of it, so we can write down here. So you find here you find here determinant of that alpha cube minus I1. So from the characteristic equations and the lectures of tensors, we have already known that. So these are known to us. So I2 lambda minus I3 is equal to 0, right? So I1 is the first invariance, I2 is the second invariance, and I3 is the third invariance, right? So this is the first invariant. So we know already that this is the first in this is the first invariant, the second invariant, and this is the third invariant. So what are the values of that? Here I1 is sigma 1 1 plus sigma 2 2 plus sigma 3 3. I2 is here. We have already we know all about that, right? So it's determinant of this sigma. Yes, sigma 1 1 sigma 2 2 plus sigma 2 2 sigma 3 3 plus sigma 3 3 sigma 1 1 minus sigma 1 2 whole squared minus sigma 1 3 minus sigma 2 3 whole squared, or we can write down this in following notation or something like that. So we can also write down here I2 here sigma 1 1 sigma 1 2 sigma 1 2 and sigma 2 2. Determinant of that plus sigma 1 1, sigma 1 3, sigma 1 3, and sigma 3 3, determinant of that, and plus sigma 2 2, sigma 3 3, sorry, sigma 2 3, this should be 2 3, sigma 2 3, and sigma 3 3. So this is second invariant. And what is the third invariant? Third invariant is nothing but the determinant of the tensor sigma, determinant of the whole tensor sigma. Okay, so these are the three invariants of any stress tensor. So this is scalar tensor. So we'll likely to know what the significance of this stress tensor. Sorry, this should be the three. So this can be written in tensor rotation. So sigma I1, the first invariant is nothing but the sigma kk, right? II or jj or something like that. And sigma 2 is half, sorry, half, first bracket, sigma kk whole square minus minus sigma ij times sigma ij, third bracket, and sigma I3 is the determinant or something I j k sigma I1 sigma j2 and sigma k3 or determinant of whole sigma, something like that. So what is the physical interpretation of the invariant? Physical interpretation. So what is the physical interpretation, right? So how we use this invariance in our real life problem or something like that. So we would like to interest the physical interpretation. Physical interpretation. So what is the physical interpretation? So physical interpretation is that the I1, that means the first invariant is nothing but is the hydrostatic stress, right? Related to hydrostatic component of the tensor. It's related, is not the hydrostatic component, but is related to hydrostatic component. So hydrostatic component, right? So how would I know hydrostatic component is equal to 1 by 3 sigma ij, sorry, Kronecker delta and sigma kk, right? So sigma kk is related to the hydrostatic stress, hydrostatic tensor. And what is the significance of the second invariant? Second invariant tends to be related more to the deviatory aspects of stress and strain. For a stress tensor, it is closely related to the von Mises stress. So it is related to deviatory stress, deviatory stress. And for a stress tensor only, it is closely related to the another stress, von Mises stress, VU and von MI, Mises, AMI, SS, von Mises stress. And I would also discuss all about this in the next lectures. And what is the invariant of the third invariance or something like that? Third invariance, right? So finally, though it doesn't seem to have any physical significance as the determinant of a stress or stress tensor, but it does when applied to the deformation gradient. So it has significance to the deformation gradient. Deformation gradient. Yeah, gradient. So when you see the deformation or strain lectures, then you will see the deformation gradient is related to the third invariant of that. In that case, so in the deformation case or something like the deformation gradient, so I3 is related to, say, I3 is Vf divided by V naught. The ratio of deformed initial volume, which is 1 for the incompressible materials, like the deformed initial volumes and deformed initial volume and the final stress volume. So this is the determinant of that. So these are the invariant, or these are the invariant of stress or something, and their physical stresses. So there are a lot of examples so we can give. So say for example, if we have any distance, let's say the example I'm giving here: 50, 30, 20, 30, minus 20, minus 10, 20, minus 10, and 10. And what is the first invariance? First invariance is nothing but the traces of. So the I is equal to 50 plus minus 20 plus 10 equal to 40. So this is the first invariant is 40, and this is scalable, right? What is the second invariant? Second invariant is 50 times minus 20 plus minus 20 times 10 plus 10 times 50 minus 30 square minus 20 square and minus 10 square. So it's minus 21. So what is the third is determinant of sigma is minus 2.8. So these are the same thing, something. So this is the invariant. So if this tensor is rotated, or the coordinate of this rotated, then this invariance would never change. That's why these are called invariant, and the invariant that doesn't vary, right? Yeah. So I hope you have enjoyed these lectures, and I'm going to see you on the next lecture as well. Thank you very much.